Imagine you're standing on this crowded street. Cars are rushing past, people are talking, and lights are flashing all around you. The experience feels total. The concrete beneath your feet feels solid, and the events unfolding around you seem objective and immediate. But your eyes don't actually capture the world like a camera. They collect scattered fragments of data, while your brain functions as a live rendering engine, painting over the gaps in real time. You have a blind spot in your visual field where the optic nerve connects to your retina, yet your brain automatically fills it in, so you never see the whole. Your mind reconstructs the reality around you before you ever become aware of it. We can see this reconstruction in action by testing a seemingly stable image. Here, a cylinder casts a shadow on a checkered plane. Square A and square B appear as different shades, but as a solid gray bar slides across, the illusion breaks. They are identical. Your brain unconsciously lightens square B, assuming how shadows behave. Your baseline experience of the physical world is, in a sense, a controlled hallucination. This biological translation extends to our fundamental understanding of space and time. Objects do not possess intrinsic color. They reflect wavelengths of light, which the brain translates into the experience of red or blue. Sound works the same way. A vacuum is silent. Voices and music are simply the biological interpretation of air vibrations. This delay represents the time it takes for neural signals to reach your conscious awareness, usually around 300 milliseconds. Your brain receives these staggered signals and stitches them into a smooth narrative after they have already happened. Because of this lag, we are constantly living a fraction of a second in the past. The brain expends massive energy editing these delays for a specific evolutionary reason. Under a theory called predictive processing, your brain is actually guessing what will happen next and comparing incoming sensory data against those expectations. Evolution rewards speed and survival over 100% accuracy. If a simplified reality helps an organism stay alive, the brain will choose the simplification every time. This applies to our memory as well. Instead of replaying fixed files, your brain rebuilds memories from scratch each time you recall them, making them malleable and prone to change. Your brain prioritizes constructing a fast, manageable model designed to keep you alive within a raw universe that is far too complex to perceive directly. At the quantum level, the solid world disappears. We find a chaotic landscape of ghost-like particles suspended in empty darkness. What we perceive as stable matter is actually empty space, governed by invisible forces and probabilities that our senses never evolved to grasp. Scientists compare perception to a computer desktop. Drag a file to the trash, and you don't see the binary code underneath. As the code resolves into a simple icon, you see only what is useful. We don't need quantum mechanics to navigate a tree. The external world is real, but your brain hides its incomprehensible complexity behind a stable interface of shapes and colors. This realization changes the way we look at human interaction. Because our brain's predictions are built from our unique memories, our individual biology, and past experiences, no two people use the exact same rendering engine. When two people disagree about an event, they are often reacting to two slightly different simulations. Their brains have filtered the same raw data into different interpretations of what is objectively true. Conflict often stems from the assumption that we are all seeing the same world. Empathy becomes more accessible once you accept that the person across from you is literally inhabiting a different model of reality. Science still struggles to explain how physical matter creates subjective experience. From billions of neurons firing in a pitch-black skull, your brain manages to generate the vibrant, shared hallucination